Good evening. Now we are going to be with Cauchy's equation, or we can say Euler's equation. Now this equation actually we have with variable coefficients. So Cauchy's equation, this is with a variable coefficient. So we can say like x square d2y by dx square minus x dy by dx plus y, that is something q. So we are going to first reduce it to constants. Reduce to constants means we are going to make it with differential equation with constant coefficients. And once we have made this, then whatever we have applied it in last videos, that we can apply over here. So aim is to make it with constant coefficient instead of this variable coefficients. So now let us, we have this equation. You can see we have this x to the power n, x to the power n minus 1. Likewise we have, and q is f of x. So now we are going to consider, so we have, it can be reduced to linear differential equation with constant coefficients. So main aim is this one. And once it with these coefficients, then we can use short method, or we can go with method of substitution. Method of that last we have seen. So we are going to use that u into y1 plus v into y2. So this method we are going to use to solve the problems. So main aim in this method is to convert into coefficients, and once you have converted, then you can use short method, or you can use second method which we have seen, method of variation of parameter. Method of variation of parameter. So we can use any of these methods to solve the problems again, because now that problem goes to constant coefficients. So now let us, we will assume that z is equal to log x, and then if we will take derivative with respect to x, oh okay, we are taking anti-log on both sides, so we have e to the power z equal to x, and we will take derivative of this with respect to x, we will get dz by dx equal to 1 by x. Now we have dy by dx. So by chain derivative, we can write it as dy by dz into dz by dx. This dz cancel. We have dy by dx. Now we have dz by dx as 1 by x. So we will put value of dz by dx as 1 by x in this equation. And then we will get dy by dx equal to dy by dz into 1 by x. Now x we will take on left side. So we have x dy by dx equal to dy by dz. So x dy by dx equal to dy by dz. Now this dy by dz, we will write it as capital D. So we can write is d is equal to d by dz. And therefore this we can write it as equal to, so d of y. So we can write it as d of y, that you can see over here. So we have this x dy by dx, that is equal to dy, and d we can write it as d by dz. In last, these two methods we are using d equal to d by dx. So now we have x dy by dx equal to dy by dz. Now we will take this portion, dy by dx, and we will take again derivative with respect to x. So you can see d2y by dx square, derivative of this. Then we will take x into y, sorry, u into v in derivatives. So we have u as it is, so dy by dz as it is, and derivative of 1 by x we have minus 1 by x square. Then we have v as it is, so 1 by x, and now dy by dz. So we have to take derivative with respect to x. So we will take d by dz into dz by dx. So try to understand this. So if I will write on this side, so we have it as dy by dz, and then we are writing it as, we have to take derivative with respect to x, so it becomes d by dx of dy by dz. But we are interested with d2y by dz square, because here we have taken d equal to d by dz. So we have to write it also in terms of d by dz, and therefore we can write it by chain derivative d by dz into dz by dy. So we have taken one extra dz, we will take here, and dx which we have removed we will write over here. So same we have written over here, d by dz, this is dy by dz, bracket dy by dz, whatever we have over here, same we have to write over here. And this dz we do not have, so we have by chain derivative dz, and this dx we have over here. So we have 1 by x, d by dz, dy by dz, dz by dx. Now again dz by dx, we know this already we have calculated 1 by x. So we will put it as 1 by x. So this 1 by x already we have, and of that dz by dx, so it becomes 1 by x square. Now in both terms we have 1 upon x square, we will take on this side, and from this we will get it as x square d2y by dx square. So in first it becomes minus dy by dz, plus in second term we have d2y by dz square. Now dy by dz, so we can write it as d by dzy. So we will have minus dy, and d2y by dz square is d square y. Now from this we can take d common, and from this we will get d in bracket d minus 1 y. So x square d2y by dx square can be replaced by d into d minus 1 into y. So likewise, if we have power x cube we have, then one term will be increased, d into d minus 1, d minus 2 into y. So because only for x dy by dx we have d, then x square it becomes d minus 1, x cube d minus 2, and likewise it will be increased. So likewise we have to solve problems that is from Cauchy's equation. So now we will consider one problem, that is x square d2y by dx square minus x dy by dx plus 4y equal to sine of log x plus x cos of log x. Now we know we have to put z equal to log x. Then we have to put x square d2y by dx square, and that we have to write equal to d into d minus 1 into y. Then we have x into dy by dx. We have to put it as dy. So now we will put these values, and from this we will get it as d into d minus 1 minus, we have d minus this d, that is for x dy by dx, plus 4 and whole into y, which is equal to sine z, because log x we have z, plus x cos z. Now we will solve this. So from this we will get d square minus d plus 4 into y equal to sine z plus x cos z. Now from this we will get d square minus 2d plus 4 into y, which is equal to sine z plus x cos z. Now we have this equation, we cannot have roots because we can see d square minus 2d plus 4. So we will write it as auxiliary equation. Now this equation becomes our equation with constant coefficients because we have over here 1, here 2, and this 4. So we do not have variable coefficient in this. So now we will go with m square minus 2m plus 4 equal to 0. From this we will get m is equal to minus b, so it becomes plus minus root of b square minus 4ac upon 2. Then we can have 2 plus minus root of, it becomes minus 12 upon 2. So this 12 we can write 4 into 3, and 4 root outside we can take 2. So we have 2 plus minus 2 root 3. You can write I 2 root 3 upon 2. And 2 we can take common and we can cancel it. And we will get 1 plus 1 plus minus I root 3. So we have value of alpha here, that is alpha equal to 1 and beta equal to root 3. And now we can write complementary function that as yc equal to e raised to x in bracket c1 cos root 3x plus c2 sine root 3x. I is there. I c2 sine root 3x. So if I forgot somewhere, then you have to keep in mind. So we have for these roots e raised to alpha x in bracket c1 cos beta x plus I. No, sorry, no I actually. So we have plus c2 sine beta x. So I is not there. So we have c1 cos root 3x plus we have c2 cos root 3x. So we have to write in this fashion, that is c1 and c2. So now once we have complementary function, then we have to go for particular integral. So this formula you have to keep in mind. This is most important one, that is cos beta x and sine beta x and e raised to alpha x. Alpha we have 1 over here. So now we will go particular integral. Now particular integral, now it becomes easy. You can see we have this particular integral. So we have now in the same fashion 1 upon d square minus 2d plus 4. And here we have, first we have sine z and x cos z. So we have sine z and sorry, this x actually we have to write it as, because we have z equal to log x, and from this we can write that x equal to e to the power z. So x we do not have anywhere, so we have actually this x, that is e to the power z. So x we have to replace all over, so e to the power z, and this also we have e to the power z, and therefore here we will get it as sine z plus e to the power z into cos z. Now this becomes simple one. So we have to make separate over here. So yp equal to 1 upon separate two terms plus 4 sine z plus 1 upon d square minus 2d plus 4, and we have cos e to the power z cos z. Now here we can take Ez outside, and in this we can put that value a square d square equal to minus a. So we have equal to 1 upon, this is 1z, so we have minus 1 minus 2d plus 4 into sine z plus e to the power z we will take outside, and then we have z a is 1, so we have d plus 1 whole square minus 2 in bracket d plus 1 plus 4 into cos z. Now this becomes 1 upon minus 1 and plus 4. So we have 3 minus 2d. So we have to go for rationalization. So plus e to the power z. So rationalize that first term, and in second we have to simplify d square plus 2d plus 1 minus 2d minus 2 plus 4 cos z. Then this plus 2d minus 2d gets cancelled. Here we will rationalize. So 3 plus 2d divided by 9 minus 4d square. And then sin z plus e raised to z 1 upon d square, then plus 1 5, so plus 3 into cos z. Now we have d square is minus a square, a is 1, and here we will get d square again minus 1, so minus minus plus 1. So it becomes 1 by 13 into 3 plus 2d into sin z plus e to the power z. So minus 1. So 1 upon minus 1 plus 3 cos z. Because we know cos ax or sin ax, we have to put d square equal to minus a square. And in both we have a as 1. So now in this we have to separate the terms. So 1 by 13 in bracket 3 sin z plus 2d sin z plus e to the power z divided by 2 into cos z. And then if we will solve this, we will get it as 1 by 13, 3 sin z, then sin z we have cos z plus 2 cos z plus e to the power z upon 2 cos z. Now we know we have z, we have substituted as log x, and x and e to the power z, we have x. So we will substitute this value, and from this we will get equal to 1 by 13 sine of 3 sine of log x plus 2 cos of log x. Then we have e to the power z, that will be x. So plus x by 2 cos of log x. And this is my particular integral. And now when we will write solution of this, then we have solution for this particular integral. So y, that is equal to yc plus yp, and then we have y that is equal to e to the power x. So c1, here we have cos alpha is 1, so cos x plus beta is, sorry, alpha is 1, beta is root 3. So we have root 3x. So we can see over there. So we have cos root 3x plus c2 sin root 3x root 3x plus c2 sin root 3x. So this is our complementary function. Now we have particular integral, and that is plus 1 by 13 1 by 13 in bracket 3 sine log x. So 3 sine of log x plus 2 cos of log x plus 2 cos of log x, and then last term plus x by 2 plus x by 2 cos of log x. So we have, this is value of y, or we can say this is solution of the differential equation with coefficients, we have variable. So this is most important. We have to first make constant coefficient, and then we have to apply this short method, or we can say method that is by variation parameters. So we have to go for this. So now we will stop here only. Remaining part we will see in the next lecture. So thank you.